So in this video, you're going to learn how to use the G.C.F. to turn a polynomial equation into an equation that's in factor form so that we can go ahead and find the roots of each of these equations, which is the same thing as solving the equation by using the zero product property. So let's just remind ourselves what G.C.F. stands for, which is the greatest common factor. So we're going to be looking at each term and finding out what the G.C.F. is for both of those terms so we can put it in factor form. And factoring is the same thing as putting that expression, or in this case equation, into factor form. So again, when we're solving these equations, we're going to be using the zero product property. So in order for us to use that, we need to have certain things be true. One of them is that one of the sides needs to be zero. That's why it's called the zero product property. And that you have it in factor form. And let's go ahead and start with the first example. So I'm going to break down each of the steps, and then we're going to write them on the side, and we're going to do the actual step as we go over what each step is. So the first one is setting one side equal to 0. Sometimes it's given to you guys, like in this example here, and sometimes it's not, so you have to do that first before you try to put it in factor form. So since it's given to us, let's just rewrite the equation on the side. The second is where the G.C.F. comes into place. So the second step is finding the G.C.F., which is the greatest common factor. So in other words, I'm looking for a number that's going to divide each of the terms and for the most amount of variables I can pull out from each of the terms. So if I'm looking right here at my coefficients, which is the 2 and the 8, the biggest number that I can divide 2 and 8 is 2. So part of my G.C.F. is going to be 2. Now for the variables, I have x to the second power in the first term and I have x on the second term. That means that I can pull out an x from each of those terms. So my G.C.F. here is going to be 2x. Let's jump into the third step, which is writing your equation in factor form so that we can use the zero product property. And it's fairly simple to put it in factor form once you found the G.C.F. So factor form means that you're multiplying items. So because we're going to be multiplying, factor form is set up like this here. So we're going to have parentheses equals the 0. And the outside factor is going to be the G.C.F., which is 2x. And the inside of the parentheses is going to be whatever's left after I divide by the G.C.F. So if I have 2x to the second power and I divide it by 2, then I have 1x, or just x, which is essentially the same thing. If I take 8 divided by 2, I get 4. And I had an x, but I pulled out an x in my G.C.F. So it's just going to be x plus 4. And then again, equals 0, like the equation was given to us. So what I'm highlighting right now is your equation in factor form. So once it's in factor form, then it's what we covered previously using the zero product property and finding the roots. So the last step will be to look for the roots. But once it's in factor form, it's just a matter of creating your equations and then solving for x. So my first equation is going to be the outside factor, so 2x equals 0, or the inside of the second parentheses is your second equation, which is x plus 4 equals 0. Then we go in and we solve for x on each of the equations. We get 0 for the first one. So 0 divided by 2 is 0. And then we subtract on both sides on the second equation to leave x alone, to isolate x, and we get x equals negative 4, because the 0 minus 4 is negative 4. So our roots here are 0 and negative 4. If I were to be graphing these, the roots are also called the zeros, which are also your x-intercepts. So these will be 0 and comma negative 4 will be your x-intercepts. But we're just finding the roots right now. We'll worry about graphing later on. So that's the first equation here. So we're going to be following always those 4 steps when we are looking for the roots when your equation is not given to you already in factor form. Yeah, I just realized that the last step, I repeated it 3, but the last step is 4. So let's go ahead. Like I said, let's follow those 4 steps again and do the second example. Unlike the first one, on this one, you notice that we are going to have to do something for step 1, which is setting the equation equal to 0. So let's just rewrite the equation here. And you can pick either side to be 0, the left or the right. Usually I go with the one on the right. So if I wanted to cancel 15n, I do the opposite, which is minus 15n. And I get 0 on one side, which is what we wanted. And on the left side, I can't combine the 6n to the second power and negative 15n because they don't have the same exponent. So we're just going to rewrite the equation with the 2 terms there because they're not like terms. So that's our first step, making one of the sides 0. Second step, as we review from the previous problem, is going to be looking for the G.C.F. So if I'm looking at 6n to second power and 15n, and I'm looking at the coefficients, the 6 and the 15, the biggest number that goes into both of those is 3. So part of my G.C.F is going to be 3. And similar like the other one, we have n to the second power and n, so I can pull out an n from each term. So my G.C.F is going to be 3n. Once we have the G.C.F, we can write our equation in factor form. And every time you have it in factor form, you're going to have parentheses involved because you're multiplying. So let me set it up here. I'm going to have parentheses, something inside the parentheses equals 0. On the outside is our G.C.F, which is 3n. And on the inside is what we get after we divide. So 6 divided by 3 gives us 2. N to the second power, you took out an n, so you only have n left, minus 15 divided by 3 is 5, and you had an n, and you took out an n, so it's just going to be 5, negative 5. So here is our polynomial equation in factor form. Now we can go on and find the roots by using the zero product property, which means I'm going to set each of my factors equal to 0 and solve for the variable. Now, I don't know if you noticed, but the G.C.F, when you set up that equation, it's always going to be 0. So you can save some work if you recognize that outer factor outside the parentheses, it's always going to be 0. Let's go ahead and do the opposite to the left side, to the equation on the right side, so we can isolate n. And I don't know, but I always split it in half, so it's just to separate my 2 equations. Makes it easier to recognize the 2 different equations. And since 2 doesn't go into 5 evenly, we're just going to leave it as a fraction. If you wanted, you can turn it into a decimal, but it's not required. So our roots would be n equals 0 and n equals 5 over 2. So you saw now an example where you didn't have to set one of the sides equal to 0 because it was already given, and you had another example where you had to leave one of the sides to be 0 by doing the opposite. And that's how you are going to be using the G.C.F to factor and to finding your roots.